All right, so let's start with this problem right here. Let's just do a quick review. Really? Okay. If already my laptop wants to be difficult. Just turned you on. See how this goes. All right, so let's graph. Why is it doing this? Of course, when I start recording, it's going to be difficult. Sorry, guys. Technical difficulties. Give me 1 minute. I was having issues with my internet yesterday, too. All right, so graph f of x is equal to 8x. What is going on? Eight x minus 2x squared. I'll say it even if it won't let me write it. 8x minus 2x squared. Okay, I want to do one like this because I didn't do one like this last week, and it definitely is going to come up. It's actually easier, but sometimes students don't realize it because you're used to seeing quadratics look like ax squared plus bx plus c. You're used to this, right? So the first thing we want to do is rewrite this and put the negative 2x squared first, okay? Negative 2x squared first. So that's going to look like, why is this being like this? It's not because it's hot. So when we write it with a higher power first, that just makes it look more like the form we're used to looking at. That's all, okay? So you have to just make sure that the signs follow your coefficients, right? So that's a positive 8x, so you put plus 8x. Now, when we completed the square, okay, remember what we did first was group these two together. I don't have a C, okay? If you want to write that, you can, but really and truly, there's no, like C value to kick out or put off to the side. What do I need to do next? What do you guys think? Anybody remember?
Okay. Factor out at -1?
Well, I want actually more than that. I want to take out this -2.
Oh, okay.
Because I want a positive 1 in front of the x squared. So see, now on the inside of the parentheses, we have a positive 1 in there. And then what that's going to do is I factor -2 out of positive 8x. This becomes minus 4x, right? So all I did was factor that out. Okay, so just a reminder that you have to, you need positive 1 as a coefficient on x squared. Oops, on x squared, okay? All right, so now what we're going to do is take this middle term, -4, I divide by 2, and then I'm going to square it. So that's -2 squared, which equals 4. Okay, so this is -2 times x squared minus 4x, and I'm going to add 4 and subtract 4 inside the parentheses. So I'm adding 0. Basically, I don't want to change it. All right, so then I have -2 times this x squared minus 4x plus 4. What do we do next? Anybody remember?
Kick out the -4?
Yeah, I'm going to kick out this -4. But remember, it's not just -4. It's -4 being multiplied by -2. So I'm kicking out -4 times -2. And that's the part where probably if a mistake is made, it happens right there. We forget that commonly, okay? So this is going to be, I think, am I breaking up at all?
No.
No.
Okay, good. Because I'm like, is this running like this? Because my internet's running slow? Why am I having a hard time writing on this pad? What is, while I'm waiting, how do I factor x squared minus 4x plus 4? What is that going to look like?
X minus 2 squared?
Yes, very good. Why is it doing that? I'm sorry, you guys. I don't know what is going on with, I don't know if it's OneNote acting up or if it's my laptop, but it is being very bratty, to put it nicely. All right, so here we go. -2 times, this is x minus 2 squared, and then we have plus 8, okay? So what this tells us is our vertex. Remember, this gives us our vertex form, okay? So we're going to get 2 comma 8. And it's always the opposite of what you see inside of the parentheses. So if it's a -2, it's actually a +2 on your x coordinate. The 8 stays the same sign, okay? The other thing you should notice is, how does this open up? Or how does this open? Does it open up or down?
Down.
Down. Because a equals -2, right? Okay. Now, my intercepts. So once, to graph this, what you need basically is your vertex and your intercepts. So we're going to take our original function, f of x equal to 8x minus 2x squared. And I'm going to do the case where x is 0. That's my y-intercept. I want to do the case where y is 0. And that's my x-intercept, right? So this is going to be, x is 0 is real easy, right? F of 0 is 8 times 0 minus 2 times 0 squared, which is just a big fat 0. So my y-intercept is going to be 0, 0. Now x means we set this equal to 0. So I'm going to factor out a 2x, and I have 4 minus x equal to 0. So this is where it's actually easier right here, because I don't have to do like the guess and check, right? It's just factoring out a common factor. So we have 2x is equal to 0, 4 minus x is equal to 0. And divide by 2, x is 0, and add x, just because it's quicker. So I get x is 4. So my 2x intercepts are 0, 0, and 4, 0. So now with all these points, we can draw a really nice graph of this. All right, never mind. Just draw my straight lines myself. Here's x and y. And then I have 0, 0, and then 1, 2, 3, 4, and 4, 0. Those are my x-intercepts. 0, 0 is also my y-intercept, and then my vertex is 2, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Go over 2, up 8, and it opens down. So everything is gonna work out nicely here. Okay. I don't want you to do that. Any questions? You guys feel okay with that? All right. Here's one for you to do. So I know this is a review, but now I'm going to, based upon this next problem, I'll lead into the next section. But here's one for you. I want you to graph the function f of x is equal to x squared minus 2x minus 8, labeling the vertex and intercepts. Okay. So I'm going to give you a couple of minutes to work on that. Oh, let me turn off. All right, I just made the chat public too. So just, if you do post anything in the chat, now it's public. Okay, so I'm going to start working on it on the screen because you should have had some time to get started. When you should have noticed there's nothing to factor out. You just got to take half of the middle term and then square it. Okay. Okay, let me see. I'll pause here for a minute. Okay, hopefully I didn't go too fast there. But you should have gotten as your x-intercepts 4, 0, and negative 2, 0. And then your y-intercept is 0, negative 8. Are there any questions from anyone about how we got the vertex or the intercepts here? All right. How about this? Can you guys just give me a thumbs up if you got this, if you're good? This is all nice and... All right. That's helpful to me because then I know if I need to talk about it some more. Okay, thanks. All right. So now we graph, right? So here's my graph. So 1, 2, 3, 4. There's my 1 x-intercept, negative 2, here's the other, 0, negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. It's down here. And it does open up. Whew, okay, and my vertex is 1, negative 9. All right, so this was not long enough. Here's negative 9. That wasn't very good. So negative 1, I'm sorry, 1, negative 9 is right here. So we see a parabola that opens up, comes through this x-intercept, y-intercept, hits the vertex, and then is going to scoop back up. Okay. Any questions on that? All right. So now what I want to do is let's talk a little bit about 8.9. Okay. 8.9. We're going to come back to this, so hang on to that in your notes. Hopefully you have it written down. And 8.9 is solving non-linear inequalities. Okay. Now, earlier this semester, I spent a lot of time talking about what looks like a line and what doesn't. And part of that was in anticipation of this section. Okay. So examples, let's look at examples of linear inequalities. Like first understand, what does that look like? All right. We've already done a ton of these, okay? So here's an example. Negative 2x plus 4 is less than or equal to 8, okay? Why is this linear? Does anybody know? Can anyone tell me why this is linear? Okay. Because, yes, thank you, Marianne. Marianne put it in the chat. Beautiful. The highest power is 1. The highest power on x is 1. Okay, so that's what makes it linear. And so if we solve this, we just follow the same rules we would an equation with one little exception. We're going to subtract 4, and then I have negative 2x is less than or equal to 4. And then what happens when I divide by this negative 2? We got to remember to reverse the inequality. And so x is greater than or equal to negative 2. So remember, that's all the numbers. What this meant was it would be all the numbers, including bracket, this way, right? So, and we wrote this, we took time to write this in interval notation, okay? So that was a linear inequality. Another example is if I had something like this, x plus 5 over negative 3 is greater than, say, 2. Okay, now this is a fraction, but where is my variable? I want to note. Same thing here, highest power is 1. Okay, it's the same thing. But this one is a fraction, but the variable is not in the denominator. so it's linear. Okay. And that means that the graphs, when I say it's linear, even though they're inequalities, it means like the graph is just a line. If we were to graph this, well, on here it's the number line, okay? But if we did put this, if we did make it a function, it would be a line. That's the point, okay? So here, when I multiply by -3, okay, remember we reverse the inequality. That's true, Marianne. Although it doesn't have to be the case, it can be a curve. A curve follows the same thing. So that doesn't necessarily mean it's a line, but you are right, okay? So when I multiply by -3, I have to reverse my inequality and I get x plus 5 is less than -6. Subtract 5, and then x is less than -11. And remember, that was open circle this way, and it was -infinity to -11. So that's just a review. We've done this already, okay? Now, what chapter 8 is going to do is introduce inequalities that are nonlinear. So when it doesn't look like these are lines, but we can always, if I had written this in a notation like this, anyways, I'm not going to go into that because it's not going to help right now. So nonlinear inequalities. So what do these guys look like? Well, here's an example. Solve x plus 2 over x plus or minus 3 greater than or equal to 0. Okay. So notice 1, the highest power is 1. So that doesn't tell us anything, but what does tell us something is the variable is in the denominator. When you have a variable in the denominator, it's a rational function and it is nonlinear, okay? Okay, so a variable in the denominator is nonlinear. This is not going to be just a line if we tried to graph this. Now, if we tried to solve this the way you do the linear ones, we run into trouble, okay? So let's just try it. Let's try to solve this the same way as a linear. If I can spell. Okay, so a linear would just say, okay, let's clear fractions. So I'm going to take this fraction and multiply by x minus 3. Okay, and that clears the fraction and we get x plus 2 is greater than or equal to 0. Subtract 2 and x is greater than or equal to -2. Okay, now let's check some of those solutions. If I pick a number greater than -2, let's say, so this is from -2 to infinity. Let's say x is, we'll try -2, 5, 1, and 3. Okay. So let me just make a little chart here because this will give us plenty of options. All right. All right, so my function is x plus 2 over x minus 3. So x plus 2 over x minus 3 greater than or equal to 0. So I'm checking to see, since this is in the solution of, this is in the realm of solutions, okay? It's the numbers between -2 and infinity. So I just want to see, are these really going to work? So let's see. If I have -2 plus 2 over -2 minus 3, that's going to be 0 over -5, which is just 0, and that is greater than or equal to 0. This one checks. Okay, let's try 5. 5 plus 2 over 5 minus 3, greater than or equal to 0, gives me 7 over 2, and yes, this one checks. It is greater than or equal to 0. All right, let's try 1. 1 plus 2 over 1 minus 3. You guys understand, I'm just using the function I was given. X plus 2, I'm checking this. Don't lose sight of that. So 1 plus 2 over 1 minus 3 is 3 over -2. Okay, that's not greater than or equal to 0 because that's a negative number. So there's no way that can be positive. So this does not check. Sad face or worried face. Okay, so x plus 2 over x minus 3 greater than or equal to 0. I have 3 plus 2 over 3 minus 3. And that's 5 over 0. Okay, this is really bad because I can't even, that's a domain restriction. Okay, this breaks my function. Remember, you can never, ever, ever, ever have 0 in the denominator. Never. So no, that one's really bad. Okay, so I end up getting a solution that is not true when we solve it the normal way. I end up getting something that does not work. So the solution that I solve for, and I probably, so this solution set where x is greater than or equal to -2 is false for some of the numbers. Okay, therefore, it is not the solution set. Okay, it has to work for all numbers. All numbers in your solution set have to make this inequality true. Otherwise, it is not possible. Okay, so let's look back at the quadratic that we graphed. F of x is x squared minus 2x minus 8. And I'm just going to go back and copy my function. I need that graph. Okay. This is one good thing about teaching on a tablet. As long as it works, I can just copy and paste. I actually really love that feature. Okay. All right, let's look at this function here. And what we're going to do is, so we need a new strategy, new method. And it is called the sign chart of a function. This is what students usually have not seen before, and you will use a lot from here on out all the way through calculus, okay? Now, the sign chart of a function is just what it says it is. It is the sign chart of a function is a snapshot of the outputs of a function. It asks, okay, it records the signs of the function's outputs. or y values. Okay. So, i.e., where are the y values positive? Okay. Where are the y values negative? Okay. So when I look at this function here and what we do, I'm going to look at this and where are my y values going to be positive? Well, if we look at the graph here, they're positive when they're above the x-axis. Does everybody see that? This is the y values or outputs are positive. Okay? So that means below the x-axis, what are all my y values down here?
Negative.
Yeah, the y values or outputs are negative. Okay? So these actually fall, while it's nice to highlight lines and stuff, and that's, it's a nice visual. What we want to do is be able to state this. You can see they're like intervals, okay? So if I draw this, this is the x-axis. This is like my x-axis. That looks like z-axis. X-axis. Okay, so I'm gonna like basically take this x-axis and just kind of put it down here and draw it more nicely than that. And on my x-axis, look at these points. This is the point -2, and this is the point 4. This is a 0 of the function, meaning that when we put in -2 and 4, we get out 0. Those are the x-intercepts. So note the x-intercepts are the zeros of your function. That's what we call them, like short term, okay? So I really only care to put on my sign chart. Yes, very good, Marianne. Marianne's sharp with it. So I only want to put on my sign chart the stuff that is actually on my x-axis. So he's right. This is the point where the graph changes. So before this, my y values are positive. In between 2 and 4, they're negative. And after 4, they're positive again. You guys see that? So if I color code this number line, here's where all my y values are positive. And then in the middle is where all my y values are negative. Okay? And when I say this is a snapshot, what we're basically doing is taking that graph and just kind of putting the information on a number line, which is a lot easier than actually just graphing it, right? I mean, we already spent time graphing this because I wanted you to see this, but if we didn't actually have to do it to know where my inputs or where my outputs are positive or negative, okay? All right, so let's see. Let's ask some questions. So here's some questions. A. Solve. If we take x squared, I'm going to want to use this function, x squared minus 2x plus 8. And I want to know where it is greater than 0. Okay, so this is a nonlinear inequality because it's not a line, it's a parabola. Okay, and I'm asking, where are those outputs positive? So when it says greater than 0, you got to start thinking like this is the question it's asking. Where are the outputs? Let me put it more specifically. For which x values will the outputs be positive? Okay. Yes, Marian is on it. So, but you got to be a little bit careful, Marian, because this is strictly greater than 0. I'm not including 0. So the answer would be from here to here, but not including -2. So negative infinity to -2. And then from 4 to infinity. And because it's not, there's no equals, means we don't include the zeros. Questions on that? Am I making this crystal clear how we got those intervals? Okay. The outputs are positive from negative infinity to -2 and from 4 to 0. Now, if the question said, instead, let's do part B. What if the function asks for when the outputs are less than or equal to 0? Now, again, this question here is asking for which x values will the outputs be negative? Okay, where are my outputs negative? Yes, good. That's going to be from -2 to 4. And since it has an equal sign includes the zeros. All right, so I'm going to say from -2 to 4 included. Okay. Any questions? Everybody see these are, so let's just quickly review this, okay? We had this function x squared minus 2x minus 8. We graphed it using what we know about vertex formula intercepts, okay? Then we looked at this quadratic function. We looked at the graph of it and decided, or like collapsed everything down into the x-intercept. So my sign chart highlights the y values where they're positive from before negative, from negative infinity to -2, just like here. Okay, positive. This is the where they're positive. Okay, here and here. And then it also highlights where my x values, or where my outputs are negative, which is this whole loop-de-loop underneath here, right? Everything under the x-axis is going to be negative y values, okay? Once we put that on the sign chart, then we can answer questions about it. I can tell very easily, I don't need the graph. I can just look at that sign chart and say, where are the outputs positive? Where are they negative? Any questions? All right, I have about 4 minutes left. So let's look at a graph and make a sign chart from this graph, okay? So given the function below, yeah. given the function below, which is this is the function. I will give you the formula. G of x is x cubed minus 7x squared plus 15x minus 9 or plus 9, which is this, x minus 1 times x minus 3 squared. Okay, so this is the factored form. Okay. Now, we don't know how to graph that, and we're not going to do that in this course. That's for pre-calc. You'll do it in 1800. So I'm going to give you the graph. Okay. And here's -9. And my graph comes up like this. This is a 0. This is a 0. This is the y value. Come on, I don't have time for you to freeze. Okay. I can't scroll down. So for right now. Oh, there we go. All right. So now let's make our sign chart. The sign chart, again, is a replica of the x-axis. Okay. So the two main points I'm going to put are the 1 and the 3. Okay. That's where stuff changes. So my outputs before 1, from negative infinity to 1, that's here. What will I record on my sign chart? That's this part right here. All my outputs are on that side.
Negative.
It's going to be negative. Yes. Then at 1, it switches. It goes above. I'm above the x-axis now. Okay, that's this part. So these become, the outputs become positive. And when I say outputs, I'm looking at the y values. Okay. Then after 3, I'm still above the x-axis. So it does not change again. It stays positive. So functions don't have to flip-flop. Sometimes they do. Sometimes it's positive, negative, or whatever. This one is negative, positive, positive. Any questions on that? Okay. So here's my final question. When is g of x less than 0? What would we put? Let's put less than or equal to. What do you guys think? G of x is my function. I'm basically saying, when are my outputs negative? We would put the interval from negative infinity to 1. And since there's an equals, we would include it. Okay. When is g of x, my function, I'm just writing it in notations. I don't have to write out the x cubed, blah, 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 all that stuff. When is my function greater than 0?
1 to infinity?
Yeah, except I can't include my zeros. So it'd be 1 to 3, not including 3, and then 3 to infinity, because this does not include zeros.
Okay.
If it did, if the question was g of x, and I'm over now, sorry, it would be 1 to infinity. Okay, if it were that. All right, I've taken up all my time. I will see you guys tomorrow, and we'll do more of this. So if you're like, what the, we're going to do lots of this. Have a good day.
You too.
Thank you. You
Let me